Have you ever just looked up at the sky and wondered what's really going on up there? It's not just, blue space. It's this invisible, churning ocean above our heads, the engine of all our weather and the stage for some of nature's most amazing art. So let's dive in.
Okay, so what exactly are we talking about? At its most basic, the atmosphere is this protective blanket of gases wrapped around the Earth. And yeah, it's what makes life here possible, but thinking of it as just a simple blanket, that barely even scratches the surface of what's really happening inside.
I mean, calling it air is kind of like calling the entire ocean water. In reality, it's this thin, constantly moving film of fluid. It's a super dynamic system where all the drama of clouds, wind, and storms is born.
Okay, so if it's this special fluid, what's it made of? Let's get into the recipe for the very air we're all breathing.
The recipe for our atmosphere really starts with two main ingredients. Scientists call them permanent gases because their amounts stay pretty constant. First up, you've got nitrogen, which makes up the vast majority of the air. Then, of course, there's oxygen, the one we're all pretty familiar with, right? It's what we need to breathe, and it's a gift from plants doing photosynthesis. These two are the reliable staples. But here's the wild part. The real secrets to our weather, the things that drive our climate, they aren't in those big players. Nope, they're hidden in these tiny amounts of other gases, like water vapor and carbon dioxide. Think of them like the secret spices in the recipe. They might be just minor ingredients, but they basically act as the planet's thermostat, with this huge impact on Earth's temperature.
All right, we've got our ingredients. Now, what actually gets this whole system moving? What's the engine that's driving all our weather?
Well, it all comes down to one thing, the sun. The sun's radiation is the fuel. It zips through the atmosphere, hits the ground, and then, and this is the key part, it heats the air from the bottom up. And that one simple act of warming, it sets everything, and I mean everything, in motion.
This process creates something that scientists call instability. It sounds dramatic, but it's actually really simple. Warm air rises, that's it, just like a hot air balloon. And this constant churning, this upward flow of energy, that's the heart of it all. It's exactly like this quote says. This instability is what gives us wind and clouds and all our weather. It's not chaos, not at all. It's just the atmosphere constantly trying to find balance.
And you actually see this play out in practice all the time on the weather report. When warm air rises, it creates a low-pressure area, which pulls in surrounding air. All that rising, moist air, well, that's what gives us clouds and rain. The opposite is true for high pressure. That's when cool air sinks down, pushing air out, which usually means clear, sunny skies. This whole dance between high and low pressure, that's your daily forecast in a nutshell.
So speaking of moist air, let's follow the journey of that key secret ingredient we talked about, water. It goes on this amazing trip through the atmosphere in a process I'm sure you've heard of, the hydrological cycle.
Right, we all learned this back in school, but it's easy to forget this is happening on a totally massive planetary scale, like every single second. Water evaporates from oceans and land, turning into a gas called water vapor. Then, as that moist air rises and cools, it condenses back into tiny liquid droplets. And that's what a cloud is. And finally, when those droplets get heavy enough, they precipitate, falling back down to Earth as rain, snow, or sleet.
And just look at that condensation phase in action. I mean, wow, this is what it looks like on a gigantic scale. That is a massive column of rising, cooling water vapor that has formed a cloud just jam-packed with moisture. That's a storm brewing right there.
And then, of course, comes the final step, precipitation. The water makes its way back down to the surface, and the whole journey is complete. It's just this simple, really elegant, and incredibly powerful cycle that keeps connecting the sky and the ground over and over and over again.
Okay, now for fun, let's zoom way in and look at one of the most beautiful, intricate results of all this atmospheric physics, how a single snowflake is born.
It's a fantastic question, isn't it? How does this whole system, governed by these big, broad, physical rules, produce something so unbelievably complex and unique from something as basic as frozen water?
Well, it all starts with something really, really simple. A tiny hexagonal ice crystal. Just a little six-sided speck. But as that speck tumbles its way down through a cloud, it hits all these different zones of temperature and moisture. And with every little change, it grows differently, branching out into these incredible, complex structures. Its specific journey is totally unique, and that's why they say no two snowflakes are exactly alike.
But here's the one rule they all have to follow. It all comes down to one number, 6. Because of the way water molecules lock together when they freeze, a real snowflake will always have 6 sides, or 6 arms. It doesn't matter if it's a simple little plate or a crazy complex fern, it's always got that 6-fold symmetry. Always.
And hey, here's a fun little piece of trivia for you. For the movie Frozen, the animators at Disney actually brought in a physicist who specializes in snowflakes just to make sure they got the science right. So next time you watch it, pay close attention. Every single snowflake you see on screen has that perfect 6-sided shape. You will not find a single fake-looking 8-sided one in the whole movie.
Okay, that is super cool, but let's zoom back out to the big picture again. How does all this huge atmospheric system, actually connect back to us, living down here on the ground?
Well, for one thing, the properties of our atmosphere directly affect our own bodies. Think about thin air at high altitudes. The air pressure is lower up there, which means for every breath you take, you get less oxygen. So what do elite athletes do? They go train in these conditions on purpose. It forces their bodies to adapt, to literally create more red blood cells so they get better at carrying oxygen. Then, when they come back down to sea level to compete, they have this amazing performance edge.
So you see, from the very makeup of the air we're breathing right now, to the water that cycles all around us, to the weather that literally shapes our day, even to the limits of our own bodies, it is all connected. It all happens inside this incredibly thin, delicate film of fluid above our heads. So I guess the only question left is, knowing that you're part of this amazing, intricate dance, does it change how you look up at the sky?